Hey, Simpsonians, back at it again with the next video. Still here with Andrew, trying to get this intro straightened up, but he just finds it very comical the way I open up my videos. So, how you doing, Andrew?
Good.
Good. I think Andrew would rather I be recording in a different room, but here we find ourselves, huh, bud? What? All right. Andrew and I have had quite some adventures together. You might remember him from my PowerPoint on my life where we were in Mexico City. That was a good time, huh, Andrew?
Yeah.
All right, great commentary. Let's talk about covalent molecules and how we name them. All right. So, first of all, you want to make sure you have a covalent compound. All right. So it's important to be able to identify the difference between a covalent compound and an ionic compound. Now, hopefully, you remember some of the details of what makes them different. Covalent molecules sharing their valence electrons, whereas ionic compounds are held together by electrostatic forces. We'll get to that later. So your first step in identifying a covalent compound is making sure it is made up of nonmetals. Nonmetals, okay? So no metals involved, and then you know you'll have a covalent compound. So we check that one. If that is good, then we keep going. All right, so next you want to see how many of each atom you have. And once you do that, you want to find the prefix for the first atom. So you have more rules than this on page 81 of your notebook. I'm just kind of skimming over them, the quick version, but those are more step by step if you want to take a look at those. So you get the prefix for the first atom, and you have the list of prefixes: mono, di, tri, tetra, penta, etc., etc. And a little subnote here: if the first atom is singular, leave as is. So if you have first atom that's just singular, you don't have to put mono in front of that. You just leave it as it is, okay? So number 3 is going to be to get the prefix for the second atom, okay? And this is where we would use mono, or we use any prefix if there's for however many atoms we have. And then right after that, you have to add "ide" to the end, okay? So that's something that's consistent with naming ionics as well. You add "ide" to the anion, as we've talked about, but for covalent molecules, you always add "ide" to the second atom in the covalent compound, okay? So you get the prefix for the second atom: mono, di, tri, tetra, penta, etc. And then you add "ide" to the end, okay? And if you need help with this, just think about common molecules that we talk about, like carbon dioxide, carbon and 2 oxygens, or carbon monoxide, carbon and 1 oxygen, things like that give you a basis to notice what you're putting in there. I forgot the check mark for the second one, so we do that, then we do that, and we have any named atom. And then you just have to kind of reverse engineer this to break down what you're looking at. So let's fill out this chart, shall we? So we're looking at iodine heptafluoride, okay? So first off, these are 2 metals, and I mean, we already know we're working with covalent molecules here, so we'll kind of skip that step here. If you're starting from scratch, you will have to identify that. So we have iodine here. We know that our first thing in the formula is going to be an I. Good old I for iodine. Next, we look at this. So we see the fluor here, so we know we're working with fluorine, okay? We have the I at the end, and then we have the prefix hepta. So we have to figure out what hepta, which number that tells us. So that is something you'll have to know. Hepta is 7. So we have iodine, then we have fluoride, and we have 7 fluorides. So if you're getting mixed up with subscript and exponent, you're going to want to make sure you know that a subscript tells you how many, how many of these you have. Subscript tells you how many of the preceding atom you have. So here we have iodine, and we have 7 fluorines, okay? Let's go on to the next one. So here we're given the formula NO2. Now we have to name it, okay? So first atom is nitrogen, just singular, so we put nitrogen. We don't put mononitrogen because if the first atom is singular, you leave it as is. Nitrogen, then we have 2 oxygens, okay? So 2 is going to be di, nitrogen di, oxygen, and we add "ide" to the end. Nitrogen dioxide. Okay, NO2 is nitrogen dioxide. All right, next up we have diphosphorus tetraoxide. All right, so let's look at the first one. Phosphorus. We know we're working with phosphorus. We have a di out front, so we have two phosphoruses, two phosphoruses. I meant to say this at the beginning of the video. I'm going to insert it now. Do not watch this if you haven't attempted the study guide on your own. You're not going to learn anything from just looking at this study guide or watching this video and putting the answers in. So please, if you haven't done this yet, do it on your own. Okay, if you have to watch me do the first one or something like that, okay, but you need to be trying this on your own if you want the info to stick. Even if you get it completely wrong, you'll learn a lot from doing that wrong and then learning how to do it the right way. Okay, once you struggle with something, you get a lot better. Right, Andy? Andrew? Right?
Yep.
I don't think he was listening. Okay, let's move on to our second atom in this molecule. We see the ox here, so we know it's going to be oxygen. The iod's added at the end, and then tetra. Okay, tetra is 4. So we have P2O4. That's our formula for diphosphorus tetraoxide. Diphosphorus tetraoxide. Okay, on to the next one. Again, we have a formula here, SO3. So our first atom is sulfur. Is just one of them. So again, we leave it as is, sulfur. Then we have oxygen, and we have 3. So 3 means tri, sulfur tri, ox, and we add ide to the end, sulfur trioxide. Okay, not too tough. On to the last one, nitrogen monoxide. So first element's nitrogen, obviously. Monoxide tells us that we have 1 oxygen. So all we have to do is put no. Okay, you don't have to put a 1 down here, that's not necessary. Okay, you just leave it NO. And that's for any formula you're writing. If you have a 1 of the atom, you just put the atom's letter. You do not need to put a 1. Okay, so that's it for that chart. Hopefully you're getting the hang of that. For covalent molecules, when the test comes around, make sure you know how to name covalent molecules versus the method for naming ionic molecules, which we'll get to in these videos soon enough. So when you identify it as an ionic nonmetals, when you identify it as a covalent nonmetals, then you'll be able to name it. Now, the last thing I want to talk about real quick is the diatomics. I didn't put any on this chart, but diatomics are atoms that exist in pairs. Oh, well, that's horrible. So, for example, oxygen. So oxygen always exists in the world as O2, but we still just call that oxygen, not dioxide. Alone, we don't call it dioxide. If it was in like here in nitrogen dioxide, yes, we say dioxide, but oxygen just exists as this. So there are 7 diatomic atoms, which create diatomic molecules. So we have hydrogen out by itself, then we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So on the periodic table, these 6 over here form a kind of 7, then you have hydrogen out on its own. Okay, so those are diatomics. All of these exist in nature in pairs so that they have full valence shells, okay, forming either double or single bonds. Those are the diatomics. Okay, so it's important to know that. In the next video, I'll get into some VSEPR theory, molecular geometry. So you should be able to, let's say if I gave you, which is what I did down here, I give you a formula, I need you to name it, and I need you to show me the geometry. All right, so we'll talk about that next time. I will see you guys in the next video. Anything to say, Andy?
Keep going.
Seems like a pretty similar message every time. All right, thank you so much.